The understanding of how time is sequenced. We have time now, which is what we're fundamentally experiencing at every moment, and that's represented with a one. And then we have space, which is represented with the concept of zero. And one of the equations that you have here is how time before and time now lead to time after. And something I just wanted to clarify, and I'll more than likely be putting the equations here on the screen for the video, but for right now, I'm sure you know the equation. So I just want to understand, is this essentially an equivalence where time before plus one is equal to time after? Is that equivalent to time squared, or excuse me, time before squared is equal to time after? Is there any difference in those two that's worth mentioning?
Yeah, the way I approached it in the first paper was using a type of complex number approach, and that's on pages 3 and 4 of paper one. And like the description there was quite primitive, if immature, in trying to. It was really reaching because, as I initially said, that the aim was to find the golden ratio. The issue was trying to find the right words to describe what was going on. So I knew that time after had to equal TB squared. So you have basically, um, if TA, the just going through the equations on pages 3 and 4, the the first key equation there was time after was unknown. That was to be given that I wasn't sure what time after was. And then in using figure 8 on page 4, the idea was to say that the future always represents a type of choice. And the only idea that was valid in 3 different time domains, if time now already was taken as the value of one, that only left time before. And so my only conclusion was if there is a choice in the future between two ideas, going from before to after by and now, then you could only use TB squared in that regard.
Right.
And so, yeah, TB plus one equals TA. But I still wasn't happy with that description. It still lacked a nice mathematical tone to it. So then in paper 8, I went for the new solution process. And that's on page 3 where I introduced the idea of, if I could just say it now, if time is a singularity, we can relate time before to time after along a basic linear mathematical construct via time now. And then I say this has been the Achilles heel, it seems, of our logic of time. So let's break that down further. For instance, we know that placing time before next to time now requires a negative sign for time before, given time before is a backward negative step compared to time now. So that gave me the idea of minus time before plus one equals fundamental property A. Then there's a next fundamental property that I derived. And I said, if time is a singularity, once again, we can present the case that time now can also be per minus time before as another equation, as technically time before would already be contained within the time now context, which is a type of sentience code itself, as it would have time before would have already happened in the context of time now. So then I said 1 over minus time before, which 1 as time now, over minus time before equals fundamental property B. So then when I said, okay, these are two absolute fundamental properties, they must be equal to one another if it is on a most fundamental level. So then I said, let fundamental property A equal fundamental property B, and voila, you get TB plus one equals TB squared. So there were two ways of doing it, and both seemed to arrive at the same result. But I was
Right.
happier with the paper 8 process because it just seemed to use both the negative sign and division as well.
I see.
So a more, yeah, a
So
more,
what you're describing right now sounds really similar to the results of the double slit experiment in a way, because we have two time before possibilities that lead to the time after, which is where does the actual wave or particle end up? So am I on the right track with that? Or
Yep. That's
would
described in, yep, totally. That's
yeah.
described in paper two. That's the uncertainty principle as well with the temporal wave function. And it's also in paper three how the chaos equation is derived,
Okay.
which then leads to, yeah, by multiplying both values of the quantum wave function as theta and minus one over theta, the golden ratio, you get the value of minus one. And then when you apply that to the space equation, e to the I pi equals minus one. So that's how you have that synthesis. But the problem with the
Right.
quantum wave function is that it doesn't obey the strict definition of what pi is. And the way space-time, if you're looking for a massive philosophy in this, the way the time equation tries to accommodate for the space equation is what reality is. It's just two very fundamental ideas trying to work one another out. And the result of that is what we perceive of reality and the wheel of time itself, a 26,000 year process in that derived solar system with that derived astrophysical display. Yeah.
Right.